All right, friends, as you heard, today we are talking about the future of clean transportation via hydrogen. But before we get into today's article, let's talk about today's sponsor, Mouser Electronics. Now, on this podcast, if you've been a fan, if you've been rocking with us for a while, you know we love Mouser. Now, Dan, tell the great people, why do we love working with Mouser so much?
Well, one of our, I would say the whole mission of this podcast is to try and take technology that's on the frontier, on the horizon, that we think is really interesting, and deliver it to our audience in a way that they can understand it and make it actionable in their day-to-day lives. Mouser aligns really, really well with that mission because they do the same thing. They take interesting technology trends that they're attuned to because they're in the electronics world and they're connected to all these suppliers, researchers, startups, etc. They write about these interesting technology tech trends that they see on the horizon and write them in awesome, succinct articles that are easy to understand. You can tell why we're so in tune with them because they're in tune with the mission of what we like to do on this podcast.
We're exactly. We're just so aligned with them. And this article is really a testament to that. Folks, I'm going to link it in the show notes, but just a quick glimpse of what's going on. Mouser wrote this article that goes over the history of hydrogen cars, battery electric vehicles, the competition that's going on right now, the pros and cons of each technology, and what the future looks like for hydrogen, including its potential obstacles. The reason I like it so much is that it's maybe like 4 paragraphs that are like super, super easy to digest, even if you don't have a background in, electric vehicles or engineering or any of that. It's relatable to just about anyone to walk away with the juicy bits of what's going on in this field. So I'm going to link it. I suggest everybody checks it out. It's a really solid article, a really good primer for this episode because, as we mentioned already, we're talking about hydrogen power. Now, to kick us off, let's talk about the downsides. We've seen hydrogen be like this super debated topic. Famously, Elon Musk has been a massive hater of it, saying that it's never going to happen. It's like a loser technology.
Yeah, I don't know I don't know if it's a direct quote, but he's definitely called it a loser. Definitely called it stupid at some point.
If I've heard loser, you've heard loser. He's probably said something along those lines. So let's just stick with. He said it's a loser technology.
Or we're both making up the same quote in our heads. But Elon Musk, not a fan of hydrogen electric vehicles as opposed to battery electric vehicles.
And you know what? He's not alone. There have been a lot of critics of hydrogen technology, and a lot of the criticism is kind of valid. So, for hydrogen to be viable to put in a car, you usually have to get it into liquid form. Now, hydrogen is abundant as gas, but to get it to liquid form, you have to cool it a lot, which means you have to use a lot of energy to get it to that cooled state and keep it in that cooled state, which then makes it actually quite difficult to transport as well.
Well, it's counterproductive, right? If your goal is to have super high energy efficiency and for it to be super convenient, hydrogen may not be the answer because it uses a lot of energy to store it in its liquid form. And even when it is in its liquid form, it's not super convenient, right? It's not super safe to store because of the volatility. You have to let it off gas. Otherwise, there's a chance that your car would pretty much explode. And on top of all that, I think outside of just the storage and safety, there's also some challenges with production of hydrogen, right? So current hydrogen production methods can be expensive. They can be environmentally unfriendly. And on top of all that, from an energy perspective, they're not all that efficient. So the amount of energy that goes into producing liquid hydrogen is way, way less than the amount of energy you're able to get out of it when you're consuming that energy, again, when you're trying to use it in something like an electric vehicle. So from a fundamental thermodynamics perspective, someone would say that is not efficient. It's pretty inefficient, the current production methods of hydrogen.
Yeah, and one more thing, as a consumer, hydrogen in your car does not sound like the greatest thing ever because it can blow up. You kind of mentioned it with the off-gassing, but a lot of people just aren't comfortable with like an abundant amount of hydrogen just sitting around their car either. So there's like
you fill your car with gasoline though.
I don't think that's the same. So like, the gasoline might make your car catch on fire, like maybe a little explosion, but like there's a reason that NASA invests a lot of money into like hydrogen sensors.
I love that we're now talking about how big the boom would be as a deciding factor of which fuel method for your car, but I'm with it.
I'm just saying a little boom could mean a scratch and a big boom could mean big scratches.
Ford Pinto owners would like to speak
there
with you
you go.
That, but
little car history there. But yeah, so all things to consider, and what it's amounted to is just a drastic lack of options when it comes to hydrogen cars in the market. I think Toyota's, what is it, the Mira was the first like really big one in the United States. They were selling it for $75,000. It was a bad car on every account. They were selling it for like a $45,000 discount if you wanted it, but there was only 2 stations in America where you could get hydrogen fuel, and I think they were even shutting down. So it just hasn't taken off, and that's super unfortunate because if hydrogen could be viable, it would be amazing. You wouldn't have to worry about massive battery packs. The only emission is what? Water. Like it's everything that we would have ever wanted, and hydrogen is abundant. It's what the most abundant material that we have. So like, why not leverage it if we could?
Well, and with all of the challenges that we've spoken about with hydrogen, it's actually from a purely fundamental perspective on paper, it's pretty interesting as an energy storage method for cars, for other types of vehicles, etc. Right? A lot of the challenges that come alongside with battery electric vehicles, a lot of the complaints are there's battery degradation over time. The dead weight of the battery. So a battery weighs just as much if it's 100% charged as if it's 0% charged. So, as the battery continues to discharge and discharge, you actually end up with a bunch of dead weight, as opposed to if it were hydrogen fuel that you could just let water vapor escape into the air, your vehicle would actually get lighter and more efficient as there's less fuel in the car. Lots of different reasons, right? But, on paper, hydrogen sounds great. But in practice, it's where we've encountered a lot of the challenges, like we were saying: storage, safety, cost, sustainability, production methods, etc. There's a lot of sticking points that have led to hydrogen not being the promised Goldilocks solution for the future of transportation that we've seen
sadly
just yet.
And that's the question to ask ourselves now, right? Do we give up, or is this just we're not there yet? Well, these folks at MIT, they think they got the answer, and they're sticking with we're just not there yet, but we're going to help you out. So without, I guess, I don't want to spoil it too much. This is a good story. I want to like savor it and deliver it the right way.
Okay.
We're going to go from one of the most abundant molecules in our planet, which is hydrogen, to one of the most abundant scrap metals, which is aluminum, right? Now, when you think of the soda cans you drink, they're very insignificant. They're lightweight. You throw them away. You don't think twice about them. But aluminum is actually a very special metal. It's quite resistant to corrosion and the environment around it, which is why it's so great to be used in an application like putting soda in it. But what's interesting is that what's protecting it from the environment is this oxide layer. Now, as the name implies, oxide layer is made of oxygen. So it's the oxygen that's really making it really nice. And sorry, my cat is interrupting. She's trying to make an appearance. But it's the oxygen that's making it this super material. But if you were to take away that oxide layer, that oxygen that's protecting it, it becomes very reactive with water. Now, what is the outcome of that reaction? Drum roll, please. Hydrogen gas and heat. So hydrogen is exactly what we're going for, right? But the barrier here is, how do we make that oxide layer go away? And that's what these MIT engineers wanted to crack.
No, and you hit the nail on the head here, right? Very abundant recycled aluminum material from soda cans is actually what they use in the solution. So you're not just using this as a metaphor, right? They actually use aluminum from soda cans. They actually use seawater. And like you said, there's a little extra interesting twist here. I would say there's 2 little extra interesting twists. One of them meaning, like, can we scrub this aluminum, make it in its pure form so that it reacts really, really well with the seawater to produce hydrogen? And then just like, any reaction or any person trying to get their work done, you might be going a little slow, you might be a little laggy, but you can speed it up with some caffeine. And that's exactly what they did here. They put caffeine from the form of coffee grounds in this reaction. I forget the actual enzyme. I think it's imidazole is the name of the enzyme. But
yeah, that's the active ingredient in caffeine. So and it's funny how
they take coffee grounds, they take soda cans, they take seawater, and again, another secret ingredient. I don't want to spoil it yet, but they take these 4 things, 3 of them, of which I think I could walk around and find them all in like 30 minutes. They mix all these together, and they can, in some way, get like speedy, cheap hydrogen production, which addresses a lot of the concerns we were just talking about with hydrogen production being inefficient, very expensive, not using materials that are common, etc.
Well, what's crazy is just how bizarre this discovery is. So, like, it started off with with the understanding that this reaction can happen with aluminum. So then the next question was, how do we effectively scrape this oxide layer off, right? They did a little bit of research. They found this like really rare alloy called gallium indium that if you just mix it with the metal, it does, achieve that effect. You scrape the oxide layer off, allowing the reaction to happen. So they bridged that gap, but then they noticed that there's two things that are fundamentally wrong with that process. The first one being that alloy they're using is very rare and therefore very expensive. And if this thing is ever going to scale and beat the issues that already exist with hydrogen fuel, they need to recover it somehow. Now, the benefit of, I guess, reaching that problem and having a relatively good understanding of chemistry is that you can use ions, which are charged particles, to act as magnets to these alloy particles and then extract them back. So now the question is, how do you get a cheap ionized solution or material that you can mix with this? So what do? They go out and grab some seawater. Like literally, they were like, we took bottles and we just went into the closest, I guess, where is the closest MIT? The body of water?
Got to be the Boston Harbor.
I guess the Boston Harbor grabbed
the Charles River is freshwater. So.
Oh. Yeah, well,
they must have gone to the Boston Harbor, maybe Revere Beach nearby.
Somewhere with abundant seawater is where they
go grab some seawater, and they're like, "Oh, look at this plentiful ionized solution that people like to swim in and fish in and ride the waves." Seawater,
readily available to naval ships as well, right?
Mm-hmm.
Like that's a good potential application. So they got the seawater. They were like, awesome, now we can extract this. And then they started watching the reaction happen. They're like, oh my God, it takes like 2 hours for this thing to like happen. Is there anything else we could do to make it go faster? So get this. I'm thinking MIT engineers, they probably have like whiteboards and just like looking at all these possible materials. Or maybe there's like an AI running in the background seeing what's a good fit. No. They went into a kitchen and started chucking stuff into these water bottles and seeing what would happen. And one of the things they chucked in there was coffee. And the moment they put coffee in there, they're like, "Oh my God, it's working faster."
Doesn't it feel a little bit like Thomas Edison, like trying to find different filaments for the light bulb? Like,
yes, that's
one
such
would
a good
think
reference.
that like the whiteboard approach would be the fastest way to get you the right answer, and sometimes it is. But sometimes when you're using abundant materials nearby, it just I'm gonna grab a little bit of this, grab a little bit of that, throw it in here, I don't know.
A chef making like a new recipe is like, what works? Let's just try stuff out.
That's exactly what I was thinking, right? And this is a fun analogy because we always call the technology behind our podcast episodes the secret sauce. But you're trying to get just the one last ingredient for the finishing touch on your secret sauce. Chefs are like, sometimes they're using like this encyclopedic knowledge of all these spices and how they interact with each other. And sometimes they're just like, let me grab this from the garden and see if it tastes good.
A little pinch, yeah, that's what happens.
I just grabbed a little bit of coffee grounds and boom, this reaction works so much faster, so much better, so much cheaper. I don't know.
Tim, I'm completely with you. I was just amazed by the process by which they were going through to, crack one of the biggest problems that the energy sector is facing. And what's funny is that they were like, coffee works, but why does it work? And, the engineers had hit their limit of chemistry knowledge. So they were like, hey, chemistry friends at MIT, faculty members, why is this happening? And they're like, have you looked into, I forgot the name of that enzyme. Can you remind me again?
Imidazole.
They were like, have you looked at imidazole? It's probably that. And then when they isolated it and used it, they're like, oh my God, it is that. So now you have basically all the problems solved, right? At the beginning, you could react aluminum with water if you could scrape that oxide layer. So they found the alloy that does that. But then the alloy is rare and expensive, so you have to have a way of recovering it. You need some sort of an ionized solution, and seawater accomplished that. Then the reaction is too slow, and if it's too slow, it can't scale well either, so they added the caffeine, which makes it go faster too. Now, just some numbers about what they've been able to accomplish so far by doing this entire process. A single gram of aluminum pellets in this reactor, I'm using air quotes here for the folks that are listening and not watching, results in 1.4 liters of hydrogen fuel. That's about a quarter of a gallon. And adding coffee takes a process that would usually take 2 hours to be able to be done in 5 minutes, which is just wild. The efficiency gains there are crazy. So I think, if anything, I'm walking away from this thinking I should have coffee as a part of my regular diet. It just makes everything faster.
You know, I'm not a coffee drinker. I've been toying with the idea of it too. I don't know.
Hey, this is the sign.
Maybe this MIT
the universe
research
is giving us sign.
Or George Mason University using coffee grounds to help filter seawater.
Water,
as well,
yeah.
Right? There we go.
Drawing
some
Professor
coffee
Moran.
connections here.
Yeah.
But I'm with you, man. Right, like the reaction process using aluminum, using seawater, using caffeine, and then these gallium indium alloys, which are like the part of this that is actually rare and really expensive. They found a way to recover that using the seawater. Built a prototype to like test how well this works. You mentioned some of the stats on the yield, but I think they're building a small prototype. Well, small. I think it's about 40 pounds.
Yeah.
Small reactor designed for like powering a boat or submarine.
Mm-hmm.
So then the seawater is really, really abundant. What you need are the dry ingredients of aluminum pellets, gallium indium alloy, and a small amount of caffeine. And then it's able to pool in seawater from the abundant seawater around it, and generate hydrogen on demand to power an engine, to power a fuel cell. I forget how long they think this thing could
30
power
days.
a small boat. Yeah, 30 days. So their 40-pound reactor, I think that includes the weight of the pellets, could power a small boat in the water for 30 days, which is pretty sick.
It's so exciting, again, because I feel like maybe it's just because I'm not too familiar with the ins and outs of this industry, but I feel like hydrogen has kind of been stagnating and it's been left behind with all the battery powered vehicle craze. It's just been thought of as too much of a hassle to deal with, so let's just leave it alone. Battery tech is getting better and better, so let's just invest in that. But there's so much potential here, and I'm so happy to see that it wasn't just given up on and forgotten about.
Well, yeah, the pain points we talked about, right, are not just related to production of hydrogen. It's also related to the storage and the safety of it.
Right.
One of the things that they mention here is, like, instead of using this reactor to constantly generate hydrogen and then have a huge tank holding it, they said, how about you have a small tank holding hydrogen and you generate it on demand? Otherwise, it's A-okay to hold aluminum pellets and these alloy pellets and caffeine. Those are relatively inert, sitting around all on their own. They're not going to threaten to blow up, or you have to off-gas them and lose some of your fuel. You can have these sitting around, and then all you need to do is mix in some seawater when you need more hydrogen and generate it on demand, almost like any other generator does with electricity.
Yeah, that totally makes sense. Now, to the promise we made a while ago, talking about the pros, which we usually do, and some of the cons. Dan, you and I were chatting about the cons right before we started shooting this episode. So do you want to enlighten the folks on what we were talking about?
Yeah, so pros, I think we just talked about them, right? Sustainability, cost effectiveness, improved safety. I like the idea of versatility, specifically for use in marine vehicles. Also love the idea, personally, of hydrogen fuel for airplanes, because airplanes are one area where they're really, really mass sensitive and may never be able to fully electrify using battery because of the weight, the dead weight issue we talked about in the beginning of this episode. So love the idea there, love the potential application. Some of the cons, in my mind, this is just a lack of data. So this is not to say that the MIT team doesn't already have this, but would love if they can reach out to us or if they can publish additional information. We couldn't find it looking at their paper, also looking at the short abstract that they published. We couldn't find a summary that compared this method from a per dollar perspective and also from an efficiency perspective with energy to other methods of producing hydrogen. Would love to look at that and see how they measure up. I have hopes that at some point this holds enough promise that it could blow other state-of-the-art solutions out of the water, but would love to see those compared apples to apples just to be sure. Right now, we don't have that data to be able to tell you one way or another whether it's truly quantitatively better or not.
Yeah, it's totally fair. And before we wrap up the episode, I'm going to do a quick summary of what we just talked about today. So I'll be honest, one of the craziest stories that we've talked about when it comes to the world of energy and electric vehicles. You have this huge crisis where hydrogen-powered cars don't make sense. And I think Elon Musk even called them stupid and just idiotic and a loser technology. So do we give up? No. At least that's what these MIT students said. They're like, we're not giving up on this. We have a good idea. The good idea was to take aluminum from wasted soda cans and turn it into hydrogen fuel. They had a big barrier, though. There is an entire oxide layer on aluminum that prevents its reaction with water, which is how you would get hydrogen gas out of it. But they persevered. They said, we can find an alloy that can scrape this oxide layer and result in the kind of process that we're looking for. And they succeeded. But the alloy is expensive. You have to get it back. They didn't give up there either, though. They were like, we're going to use cheap ionized solution, salt water, to get that back. And then they were just super, super crazy with it and said, what happens if we try to speed up this process that takes so long with your average kitchen ready ingredients? They chucked some coffee in there. And what do you know? It worked. It went from taking 2 hours to 5 minutes. So long story short, you can get 1.4 liters or about a quarter gallon of hydrogen fuel out of a gram of aluminum with this technology. And these folks, they're not just a little concept. They're actually making a prototype underwater glider that can operate for 30 days with 40 pounds of aluminum. And that's their next project that's coming up. To be honest with you, this is why I think these guys are the next biggest thing when it comes to the sustainable energy future for transportation.
Love it, dude.
I do what I can. Folks, thank you so much for listening. And as always, we'll catch you in the next one.
Peace.